Good morning, everyone. My name is Leon from Hong Kong, and this is my title, Rebooting the Ultrasonic Positioning System for the Ultrasound-incapable Smart Devices. The co-primary authors are Qiong Zhenling and Zhenling An. Dr. Lin is a postdoc in the PolyU, and Mr. An is a third-year PhD student. Okay, you know that it is a long-standing issue to track and locate the smart device indoors. And based on the type of the targeted devices, the corresponding solutions can be divided into many groups. For example, the Wi-Fi-based localization and the Bluetooth-based localization. Today, I'm going to revisit a very classic localization systems, ultrasonic positioning system, UPS. This is the basic idea of the UPS. We can deploy many ultrasonic transmitters in the building. Inside the building with known locations. These dual transmitters are called as ultrasonic anchors. And the transmitter broadcasts the beacon signals periodically, and the target cell receiver can receive this beacon and estimate the arrival time of the beacon signals, and then calculate the distance to the anchors. And then finally, the receiver can be determined to locate at the intersect of the three circuits. This way also called as the trilateration. Actually, the UPS was invented 20 years ago. Okay, for example, the work, the Chirp, was published in MobiCom 2001. And it is well known for its centimeters accuracy. However, during the past 20 years, UPS has never been widely used in practice. Why? One of the key reasons is that the UPS only works for the ultrasonic receivers. Today's smart devices are not equipped with the ultrasonic sensors or receivers. So these devices are deaf to the ultrasound and deaf to the UPS. To resolve this issue, much effort has been made recently. For example, the APLS published in the Census 2015. It suggests to use the near ultrasound. This spectrum is between the 20 kHz and the 22 kHz, because this spectrum can be still received by the smartphone. And this spectrum can be inaudible to most of the human beings. Unfortunately, it still can be heard by the infants or the pets who are very sensitive to the frequencies, and also its bandwidth is too narrow to deal with the bandpass. So we ask myself the question is, how can we enable the classic UPS for the ultrasound, the incapable smart devices? The answer is yes. In this work, we propose the UPS Plus, an enhanced UPS that can provide sub-centimeters indoor localization to the smart devices and operate absolutely at the ultrasonic spectrum, not the nearest ultrasound, which is beyond the hearing system of the human and pets. Before introducing our system, let's quickly review the internal structure of the microphone. The microphone subsystem contains the four main components. The sound is captured by the diaphragm and it converted to electronic signals, and then the signal goes through the amplifier filter and finally is sampled by the ADC. So the component of the amplifier is a component to increase the power of the incoming signal. It is supposed to be linear. What does it mean? It means that if the input signal is way in, and the output signal from the amplifier should be a way in, right? It's linear. However, if we input the signals beyond its operating frequency, and it will behave non-linearly. It means that the output the signals will contain many nonlinear components, for example, the second-order harmonic, and third-order harmonic. So let's check out what will happen if we input two ultrasounds into the microphone. For example, the frequency, the two ultrasounds operate at F1 and F2. Because of non-linearity, and the second harmonic component will be expanded, and you will find that, we're surprised to find that there are four new frequencies will be created. So 2F1, 2F2, F1 plus F2, and F1 minus F2. And because of the filter component, all these higher frequency will be filtered out, and the F1 minus F2 will remain finally. So it's a very interesting phenomenon. It means that if we input the two ultrasound at the frequencies of the 50K and the 40K hertz, finally the microphone can receive the new signal operating at the 10K. So the non-linearity provides us an opportunity provide a natural downconverter to pull down the signals transmitted from the speaker to the audible spectrum that the microphone can process. For example, we give the example to show our basic idea how can we use this effect. And we can use one ultrasonic to transmit the continuous wave, ultrasonic wave, and another speaker to transmit the chirp signals. Of course, they are operating in the different frequencies. And finally, the smartphone can receive and process the downconverted the chirp signal. This is a real experiment result. We have the two transmitters. One transmitter transmits 40 kHz pulse the wave, and another speaker transmits the chirp signals from the 45 kHz to the 50 kHz. And finally, the smartphone can receive the signal, downconverted chirp signals from the 5 kHz to the 15 kHz. Okay, this picture shows the architecture of our system. The LVPS Plus consists of two types of the beacon devices, the U beacon and the C beacon. U beacon is exactly the same as the beacon devices in the past UPS system, and they can transmit the beacon signals periodically. And so our contribution is to introduce the C beacon. The C beacon, the purpose of the C beacon is to pull down the frequency of the U beacon signal such that the smartphone can process, can receive and process the beacon signals transmitted from the U beacon. Okay, specifically, we let the C beacon broadcast a continuous wave. This wave exists all the time, and a U beacon can broadcast pulse the signals periodically. Remember that the downconversion happens only when the two signals arrive at the microphone. So the arrival of the time only depends on the arrival time of the signal only depends on the U beacon and irrelevant to the C beacon. So that's right. The microphone can calculate, can estimate the arrival time of the U beacon signals and calculate the distance to a U beacon. So this is our basic idea. And to deal with the multipass effect, we propose the dynamic, the chirp spectrum, the spread technique. And in details, the C beacon repeats to transmit the chirp signals instead of a single tone wave. And of course, the U beacon transmits pulse signals. As a result, you will find that the microphone will receive some segments of the chirp. Not the entire chirp, and we call this chirp as segments as dynamic chirps. So how can we detect the arrival of the chirp signal? In the past system, we can use a static template, the chirp template to correlate the income the signal, and the correlation result will spike at the beginning of the chirp, right? But this approach doesn't work in our system because our chirp are dynamic. It means that the beginning and the ending of the chirp are unpredictable. So to deal with this issue, we proposed the dynamic chirp, algorithm to deal with the dynamic chirp template. But due to the time limit, I'm not going to go to the details. If you have anything interesting, please refer to our paper. And this is the experiment result that we can see that the microphone can exactly detect the arrival of the dynamic chirp. The next question is that how can we distinguish different beacons if they are transmitted from the different U beacon? So firstly, we encode the beacon ID into the beacon signal using the FM0. And secondly, we globally schedule the U beacon to broadcast the pulse signals in different time slots so that in order to avoid the collision. Okay, this picture shows that we can successfully decode the ID from the beacon signal. Okay, this slide shows the prototypes. The left figure shows our C beacon, which is made of a powerful ultrasonic speaker. So in one room, we can only need a single C beacon. And the left picture shows the U beacon, right? It's composed of the very cheap transducer. And this figure shows the tracking accuracy. We can see that UPS Plus, or we tested our system of the 5 modern smartphones. And we can see that it can achieve the median accuracy of the 4.5 cm. And we also test our system in the different environment settings. For example, with the music, with the speech, and the multipass. And we also, in this paper, we also exploit some real-world applications. For example, we can find our AirPods because there is a microphone in our AirPods, and we compare the iPads, right? We can transmit the same files from one iPad to another iPad when they are close. And we can also track the human's behaviors by tracking the smartphone, smartwatch, right? Okay, in conclusion, in this work, we present UPS Plus, a system that enables the previous UPS to work for today's smart devices. And we use a non-linearity effect as ultrasonic downconverter approach to pull down the frequencies of ultrasonic beacons. And in the prototype, we introduced 2 beacon devices. Thank you. Yeah, so